Hello and welcome. I welcome you to the 7th lecture of this series, that is on ocean circulation. So, in this lecture we will discuss about the oceanic phenomena and how they drive the various fundamental climate or climatic processes. So, with respect to the ocean and the oceanic phenomena, the concepts we are going to cover are these 5. The first one is basics of ocean circulation. So, there we will discuss about the various types and the major oceanic currents. Second, we will move on to surface circulation, the two dominant one, that is El Nino Southern Oscillation, which we abbreviate as ENC or ENSO, and the Indian Ocean Dipole IOD. And then we will move on to understand the thermohaline circulation. As you can understand, thermo means temperature and haline means salinity. So, we will see that how in basis on the basis of temperature, that means low and high, and salinity also in terms of high and low, we will see how the circulation is driven. And fourth, we will talk about the various impacts on land. Rather, in this particular class, we will emphasize on the linkage. In this linkage, we will try to understand the relationship between gross primary productivity, abbreviated as GPP, and carbon dioxide, and also the ENSO index. So, GPP, when we talk about the terrestrial primary productivity, be it terrestrial or be it oceanic, and we will see the carbon dioxide as one of the dominant greenhouse gases, and the third one is the ENSO. So, it is a very interesting relationship we will try to understand, and that will give us a very clear understanding as far as the oceanic circulation vis-a-vis the climate or the climate change is concerned. So, friends, let us have a look at the oceanic circulation. So, what this oceanic circulation means? It means the transport of heat and nutrients across the tropics to poles. So, when we say tropics, it is around the equatorial region, plus or minus 30, generally we take sometime 35 degree north and south latitude, and then we move on to the 0 degree, that is pole on either hemisphere, southern and northern. So, through oceanic circulation we understand the transport phenomena. What is the transport? Transport of heat and nutrients from tropics to pole and vice versa. This can be divided into two different types. The first one is surface and the second one is thermohaline. In terms of surface circulation, we very often come across two broad two major phenomena, that is the trade winds and the westerlies. These are simply driven by Earth's rotation. Sometimes the Earth rotation we refer to as the Coriolis effect and the pressure differences. So, friends, the moment we talk about the surface circulation, we understand that they are mostly driven by the trade winds and the westerlies. They are again in turn driven by the Earth's rotation and the pressure difference, and also in form of gyres. Gyres means we talk about the rotating eddies that could be in either direction in terms of clockwise and anti-clockwise. And then coming to the type 2, that is the thermohaline, based on the temperature and the salinity gradient. So, it is a salinity gradient, or you say the when we talk about the gradient, it is along a higher to lower. So, we put it temperature and salinity differences also. Friends, so we have cold salty water that sinks in polar region. As all of us know, the polar region are cooler than that of the equatorial region. So, in the polar region, the water is cold and is more salty. As we know, the salty water is heavier than the lesser salty water, right. So, in turn, the cold water and salty water are heavier, and that is why they are mostly present in the polar region, and they sink because they are heavier in nature, in contrast to the warmer and lesser salty waters. So, this flows deep towards the equator. So, this flow happens more towards equator from the pole and vice versa. So, vice versa means there it is warm water and lesser salty water that defines or that regulates the direction. So, global water currents, if you can see on the figure and the diagram, the blue arrows they indicate the cold currents and the red arrows they indicate the warm currents. Friends, you see, starting from the upper left, you have the at Alaska, you have one red that is the red arrow, a warm current, and then down below you can see the North Pacific and surrounding the California region and going towards the north equatorial region and making a gyre or making a circle there, and I mean circulating there. Then you have the south equatorial down below on the left side, and similarly in the Atlantic region you will get the Norwegian and the Gulf Stream as the warm currents, which are shown in terms of the red arrows, and the others in terms of the Labrador, the North Atlantic drift, the Canary, and the North Equatorial currents. They are shown in the blue arrows and represent the cold currents. Similarly, if we come towards the Indian Ocean, we can see we have the Mozambique region. There we have the red arrows, they represent the warm currents, and similarly down below Indian subcontinent we have the North Equatorial and Equatorial counter current, then South Equatorial and South Indian and Western Australia. These currents are there, which is very well depicted using the red and the blue arrows. So, friends, what we understand from this, we understand the various surface circulation phenomena which are represented by red and blue arrows in terms of the warm and cold currents respectively. So, the major currents in terms of if we discuss in that way, in terms of the western and the eastern boundary currents. In terms of the western boundary currents, you see warm and it moves towards pole, loses heat because it is lighter in nature in comparison to the cold water or the cold currents. I am sorry. So, examples, you have the Gulf Stream, you have the Kuroshio, and eastern boundary currents cold equatorial, they move from the polar region towards equator. So, these examples we take in terms of the California, the Peru, and this particular diagram and explanation has been taken from these references given by Huntley et al. 2023 and also shown at the end. Now, friends, let us have an understanding as far as the El Nino southern oscillation is concerned, the surface ocean circulation part we are continuing in our discussion. So, the normal condition across the Pacific Ocean driven by pressure and temperature differences. In three parts we can discuss it. The first one is the strong trade winds that blow westward. Then you have upwelling and downwelling, the up and down kind of vertical circulation. So, upwelling in the eastern Pacific, and in terms of the upper level winds return eastward. So, the first one, strong trade winds blow westward, that means the warm surface water moves in westward direction, it leads to enhanced rising air in the western side. In terms of upwelling in the eastern Pacific, cold and nutrient rich water, they rise in eastward direction, and that is how they maintain a kind of cooler sea surface temperature or SST in eastward direction. And then the upper level winds return eastward, rainfall concentrated in western Pacific. In terms of the southern one, you can see the Indonesia and Australian region. Now, if we move in the contrasting situation, we will see the El Nino kind of condition where the trade wind it weakens, the surface water move in the east direction and ocean heat shifts the jet stream. So, the figure is shown in the is depicted on the left hand side is showing the El Nino conditions and the increased convection activities, and the 3-dimensional box it indicates or it represents between 120 degree eastern to 80 degree western longitude, and equator is shown in the middle, where the arrows are shown in terms of the red or the warmer region in contrast to the adjoining colder region. So, you have a increased convection in the polar region than in comparison to equator. So, trade wind weakens, Hurley circulation dominates, rising air in the central and eastern side happens, and coming to the surface water it moves eastward, that means leading to reduction in the upwelling phenomena in the eastern side, and warm water is gathered. And the third one is the ocean heat shifts the jet stream, redirecting the rainfall towards central Pacific region. Similarly, let us have a look at our means in the southern part of the Indian Ocean. So, it is we have a dipole there. It is known as Indian Ocean Dipole, IOD abbreviated. So, intensity of the IODs is represented by the sea surface temperature gradient between the western Indian Ocean and the South Indian Ocean. So, you can see on the upper figure the western side or the western region having a larger red mark. So, that is the warmer region in comparison to the lower one, where we are seeing a larger one on the south side is the warmer water. So, let us try to understand it in terms of the positive and the negative IODs, abbreviated as PIOD and NIOD, P for positive and N for negative as it is indicated, and their impacts. So, the western EIO or the Indian Ocean SST, when it rises or warms, the eastern SST also is behaving in contrast to that of western. So, equatorial eastward current is reduced, thermocline deeper west, shallower east, and the convection in terms of west moving, the more rainfall happens, and vice versa. In turn, it leads to enhancement or increase in the Indian monsoon precipitation. So, the drought risk in Indonesia to Australia is there, whereas in terms of the negative IOD, you can see the Indonesia and the Australian region receive more rainfall. So, it is just a contrasting situation in terms of positive and the negative IODs. So, what this slide we try to understand? We try to understand there is a differential pattern exists in terms of the ocean the dipole in our Indian Ocean, which is another ocean circulation phenomena explained in terms of the surface ENCO event. Now, friends, let us move to the next one, that is El Nino and La Nina. Most of us have studied before or since our high school days in terms of La Nina and El Nino. So, El Nino, we as a general note, we understand that El Nino is giving us a kind of less rainfall scenario, and La Nina is giving us a higher or a contrasting sense higher rainfall scenario. This much we understand. Now, you can see on both the figures they have been shown in black and white or in grayscale. So, on the left lower is the El Nino representation and right upper is the La Nino, and some of the regions have been marked in terms of cool, dry, or cool wet or cool. So, these kind of variations in terms of dry, wet, cool and warm. These 4 variations in terms of the terms have been utilized, and the representation of the world is shown in terms of the impacts of El Nino and La Nina. So, let us understand enhanced rainfall in terms of El Nino, enhanced rainfall in the central and eastern Pacific. Look at the region central and eastern Pacific, drought in Australia and Southeast Asia, which is of the Indian subcontinent lies there. So, we have so because of the El Nino effect, we have higher rainfall received in the central eastern Pacific region, whereas the contrast situation or the drought situation is realized in Australia and the Southeast Asia. And it leads to weakening in the Indian monsoon. Already it has been noticed or it has been recorded in 2002 and 2009. But some years as an exception in terms of 1994, 1997 they have shown normal rainfall despite having little bit of El Nino kind of impact. So, roughly 50% of El Nino years we have received droughts in case of in the monsoon season, or we say monsoon droughts in India. Now, have a look at the Indian region. A huge region has been shown in terms of the El Nino, where it is shown in terms of the region which is affected because of this. And let us move to the right hand side, where the various explanations as far as La Nina is presented, and La Nina brings the little above normal or more than normal monsoon rainfall to India, and alternatively it also if you are getting higher rainfall, so it has seen that Australia flooding has happened. So, La Nina in contrast to El Nino has or gives more normal or above normal monsoon to India, and it also have been reported that flooding has happened in Australia. So, cold central and eastern Pacific regions, here sea surface temperature varies or it increases, and wet in terms of the Australia, Indonesia and Pacific northwest region. So, similar to in the a kind of contrasting situation what you have in terms of El Nino for or over these regions. So, dry or warm in terms of the southern US or the south or the southern America, and hurricanes in terms of Antarctic has been seen to have increased, and in terms of Pacific region it has been observed to have decreased. So, the regions which have been already hatched or encircled very well depicts the impacts which are realized over different parts of the globe in terms of the El Nino and the La Nina, or you say in terms of the receiving of higher or lower rainfall or above or below normal rainfall, and drought or a flooding kind of condition. So, this is this particular depiction has been picked from the Banana et al. In book on ecological climatology published in 2015, and the thermohaline circulation, as has been discussed in the beginning. Thermo means temperature and haline means salinity. So, friends, the warm and salty water travels poleward. What do you mean? The warm equatorial region receives or the water in the equatorial regions are warmer than that of the colder water. So, warm water moves towards poleward. So, this warm water also carries some salty water that also travels poleward from the equator, and it sinks when it cooled. So, that means it loses heat there, it sinks. The Gulf Stream brings heat to the northern hemisphere, and thereby it changes trigger the abrupt climate shift. It controls the sea level patterns, drives the long term climate regulations. Friends, this enables a vertical exchange and the global heat exchange in terms of the nutrient transport. Look at the diagram which is shown so nicely in terms of the corroborative effect as far as if it is magenta in color, that means it is showing little bit warmer, and if it is blue, that means it is showing a cooler, and in between you have the yellow representation that shows an in between situation. And look at the situation of heat release to air in the polar region, and look at the situation just above Indian Ocean or the shallow warm current along the Pacific Ocean. There it is warmer. So that itself shows that we have a gradient or a differential pattern in terms of the salinity and temperature across the pole and the equator, and that leads to a thermohaline circulation. And please remember, this is triggered by the receive of solar radiation and also the earth circulation and its swirl or drift or oscillation, whatever you call it. So these two actually drivers leads to the salinity and temperature difference, and also a gradient as far as the globe is concerned. That is explained by the term of thermohaline circulation. Now friends, let us try to link them. So when we try to link, now our understanding in terms of the various drivers, the various mechanisms that explains the climate or the climate change. Here today we are talking about the circulation. We have ocean circulation. We have talked about many more in our previous slides, and few more also will come in the next 8, 9 and 10th slide of this particular week. And friends, what this diagram very well depicts is on the y axis the NPP anomaly in terms of petagrams of carbon per year has been shown, and also the carbon dioxide growth rate anomaly has been shown in terms of the unit is petagrams of carbon per year, as we know. On the y prime axis, the multivariate ENSO index, abbreviated as MEI, has been shown. And look at the pattern of the curve. NPP is shown in a dark black color in terms of curve as NPP, thin in the carbon dioxide, and the multivariate ENSO index MEI is shown in a dotted curve. So the 1982, 1986 to 87 and again 91, and you are seeing some kind of wash regions, that means corresponding to El Nino year influence. So then what we are trying to see, we are trying to understand the relationship between the global NPP, the atmospheric carbon dioxide, and the ENSO index. The first point, El Nino causes the drier conditions in tropical regions, so limiting the soil moisture. So in terms of over the Australia and south and the southern Asian region, we find this kind of conditions, and this limits or interlimits the leads to the decrease in the soil moisture. So if soil moisture is decreased, which is also very important in terms of the photosynthesis and productivity, the global NPP or net primary productivity reduces. So what we try to understand, El Nino gives a drier condition. Drier condition leads to decrease in the soil moisture. Decrease in soil moisture leads to decrease in the photosynthesis, which is represented or which we in turn leads to reduction in the net primary productivity. The third point, atmospheric carbon dioxide high during the El Nino years. So during 1980, 83, 86, 87, 97, 98, it has been found that the atmospheric carbon dioxide is high. Why? Because photosynthesis is less. Photosynthesis is nothing but the carbon dioxide withdrawal process from the atmosphere. So if in El Nino years the productivity is less, that means the less withdrawal of carbon dioxide from the atmosphere by the process of photosynthesis. So in turn the atmospheric carbon dioxide concentration is high during the El Nino years, which has been also reported during 1982 to 83, 86 to 87, 97 to 98. And the fourth point, volcanic eruptions can disrupt the trend. So, somehow these erosions, you see, volcanic eruptions leads to a lot of what you say, gaseous eruptions and including the carbon dioxide. So, if lot of volcanic eruptions are there, then the carbon dioxide concentration in the atmosphere will again shoot off, will again increase. So, ENSO carbon dioxide link, the figure shows a kind of inverse NPP and carbon dioxide link in terms of relationship at places. So, we need to understand more and more to depict or to unravel or to really study the trigonal relationship or tripartite relationship between these three variables. So, there is a noting at the end. So, La Nina has opposite effects in contrast to the El Nino. This also has been picked from the Bonan et al., which has been mentioned at the end of this lecture. Now, let us have a look at our understanding or our group what has done. So, with this bit of understanding, our group from the Spatial Analysis and Modeling Lab have tried to reveal or try to relate between the Indian Ocean sea surface temperature, which is a oceanic phenomena, okay, the oceanic part, and the sun induced fluorescence, which is represented in terms of SIF. Sun induced fluorescence is indicative of the productivity over the land surface. So, on one side we are trying to see the contribution of oceanic phenomena represented or indicated by sea surface temperature with that of the land productivity represented by the sun induced fluorescence or SIF. So, on the upper side or you say upper right hand side, we have tried to pick the database in terms of the Indian data. We have with us the vegetation type of India, and then we divided it into the 12 biogeographic regions. Why biogeographic regions? Friends, you may be knowing that if you take biogeographic regions, we will have better control in terms of studying the impacts, because India itself has various broader zones. On western side we have Thar, on eastern and what you say the northern side, the whole of eastern the northern side starting from west to east, we have the Himalayan Gulf, on the eastern and on the eastern and western side we have the Bay of Bengal and the Arabian Sea. So, we have lot of variations. We have the various types of forest. Because of this, we have tropical forest, we have a northeastern states where a lot of we receive the highest rainfall of the world in Miocene. So, what I mean to say, we have lot of variation across the Indian biogeographic regions. So, taking advantage of that, bringing or you say optimizing homogeneity among the heterogeneity, okay, optimizing homogeneity across the heterogeneity, one needs to pick the homogeneous regions, and that is why the biogeographic regions have been picked here for analysis. So, what has been done? When we found we picked it and did a monthly basis analysis, seasonal analysis, then found that the inverse SST and SIF, that means if sea surface temperature is higher, then the solar induced fluorescence, which is also indicator of NPP, is relatively lower, and this relationship is very strong in the during the onset of the monsoon period, that is the month of June. So, warm SST anomalies, so higher SIF, and cold SST anomalies, lower SIF. So, what does it mean? This actually depicts the relationship between the Indian Ocean SST and the climatology of SIF in terms of the Indian subcontinent. So, this has already been published by Varghese et al. She is the first author, and this is her PhD work from our group, and she did lot of analysis. She tried to remove the impact of many of these oceanic phenomena, as we discussed in terms of ENSO and in terms of IOD, by doing some partial correlation analysis, and then came to a good indicative conclusion that is published in terms of the revelation. The revelation is that inverse SST-SIF relationship is strongest during the month of June, that is the onset period of Indian monsoon. And we have taken help of these references. I would request you to go through this for better understanding. So, to conclude, so these are the 6 points we discussed in today's lecture number 7. So, ocean circulation including surface and thermohaline currents redistributes heat, nutrients and gases at global scale. Surface circulation such as ENSO, El Nino Southern Oscillation, IOD, Indian Ocean Dipole affects the tropical climate, monsoon and the rainfall patterns. Thermohaline circulation controls deep ocean flows and global heat transport phenomena. El Nino reduces the global NPP and raises atmospheric carbon dioxide, whereas La Nina has opposite impact, as we discussed on one side in the southern South or South Asian side, and Australia, when because of El Nino we are receiving drought, because of La Nina we are receiving more than normal or beyond normal monsoon, and sometimes leading to flood in Australia and South Asian region. So, positive IOD strengthens the Indian monsoon, whereas the negative IOD suppresses the rainfall and enhances drought. So, this is very important in terms of understanding the oceanic phenomena as far as the Indian Ocean subcontinent is concerned. Positive IOD strengthens Indian monsoon and vice versa. So, Indian Ocean sea level rise is mainly driven by the water mass. So, we are actually not studying it or discussing it here. So, friends, with this we come to the understanding of the ocean circulation pattern and how it is linked to the climate or climate change, and with respect to the tripartite curve relationship, we understood the impact of ENSO to that of reduction in the soil moisture, leading to less withdrawal of carbon dioxide from atmosphere because there will be less NPP. So, less withdrawal of CO2 is our important point here. So, this is one of the important or the dominant greenhouse gases. So, that is how the things are linked. I think with this we got a good understanding of ocean circulation contribution to that of changing climate or climate change. Thank you very much for your kind attention.